Hi guys, welcome back. In my previous video, I have discussed about glycolysis or the different steps involved in glycolysis. That is, what is glycolysis? Conversion of glucose to pyruvate. So, what are all the different steps involved in converting glucose to pyruvate? I have discussed, and then where all there is energy consumption and energy production is also discussed, and then also we have seen a concept that is NADH++ corresponds to 2.5 or 3 ATP, ADH++ corresponds to 1.5 or 2 ATP, and GTP corresponds to 1 ATP. We have seen that also, and we have also seen, we have ended our video stating what is the net ATP production in the glycolysis, that is 7 ATP are produced in the glycolysis. Okay. Now here in today's video we will be discussing the enzymes that are used in the glycolysis. Okay. One thing you have to remember here, while explaining I will say you how to remember the enzymes. Okay. 2 points you have to remember here. First point is, whenever there is ATP involved in the reaction, maybe production or maybe consumption, wherever there is ATP involved, you will be ending it with kinase. Okay? Here, glucose is a 6 carbon atom. We all know that, right? Glucose, fructose these two are 6 carbon atoms. So, the enzyme used here is your hexokinase. Hexo is nothing but 6 carbon atoms, so hexo, and the kinase is, why we are saying kinase, because ATP is involved, so the enzyme will end with kinase. So what is the enzyme that is helping to convert glucose to glucose 6-phosphate is your hexokinase. Here, one more point that we can discuss is, even glucokinase can also come in this list. In my next video, we will be discussing about each and every step. There I will explain when we will be using glucokinase, and then when again we will be using hexokinase. Okay. Now we will not discuss that. Okay. So the first enzyme is your hexokinase. Okay. Second one is converting glucose 6-phosphate to fructose 6-phosphate. Here, as I said already, glucose and fructose are 6 carbon atoms. Yes, only there is a difference in their functional group attachment for glucose and fructose. So, whenever there is a similar molecular formula, those compounds are called isomers. From chemistry we can correlate, right? So here glucose 6-phosphate and fructose 6-phosphate, they are looking like isomers. So the enzyme utilized here is isomerase. What isomerase? Phospho. Why phospho? Because glucose 6-phosphate is converted to fructose 6-phosphate. Phosphate is involved, so we are writing phospho. Glucose and fructose are 6 carbon atoms, right? So hexose. Phospho, hexo, and then as I said, it is isomerization taking place. The enzyme will be isomerase. Okay? Phospho, hexo, isomerase. Okay? Next, coming to the next step, again here if you see ATP is involved, so the enzyme will end with kinase word. Okay, so with what kinase? Fructose 6-phosphate is getting converted to fructose 1,6-bisphosphate. So here the kinase is phospho. Again we are writing phospho because phospho is there, and here fructose is involved. Fructose is getting converted to fructose 1,6-bisphosphate. So we write phospho, fructokinase. Why kinase? Because ATP is involved, we are saying it as kinase. Okay. Next, converting fructose 1,6-bisphosphate, the split reaction that is taking place, here the enzyme utilized is your aldolase. See, this is easy. It is aldolase. Okay? And here, I forgot to mention it in my previous video, these compounds are interconvertible, means this dihydroxyacetone phosphate can be converted to glyceraldehyde 3-phosphate and vice versa can take place. Okay. Again here Fructose 1,6-bisphosphate is a 6-carbon atom. Once it is getting split, the dihydroxyacetone phosphate is a 3-carbon atom, and glyceraldehyde 3-phosphate is also a 3-carbon atom. Means here both of these compounds are having 3 carbons in it. Okay? Both of these are having 3 carbons in it. So again we can say that it is isomerization reaction, right? Same number of carbons are there. Okay? So again isomerization reaction, how to write? Similar to this one, we will write here phospho. Here also you will write phospho. Here we said hexo. Why? Glucose and fructose are 6 carbon atoms, so we said hexo. But here these are 3 carbon atoms, so you say trio. Phospho trio, not visible. I am writing it here. Phospho trio, isomerization taking place, so isomerase. Okay, I hope I am clear. This is how we write isomerase enzyme. Enzyme, how we write in glycolysis. Please write the phospho, then we see how many carbons are present, and then we end it up with isomerase. Whenever there is ATP involved, we will end it with kinase. Okay, this is one part. Coming to the next part, that is conversion of glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate. Here if you see, there is NADH plus H plus is involved in it. So whenever there is NADH plus H plus, most of the time that enzyme will end with the term dehydrogenase. How here we are saying kinase, then we will say dehydrogenase. Okay, what dehydrogenase? Same thing, glyceraldehyde 3-phosphate 3-phospho, sorry, not phosphate, 3-phospho dehydrogenase. This is the enzyme used. Okay, glyceraldehyde 3-phospho dehydrogenase. Okay, then next conversion of the 1,3-bisphosphoglycerate to 3-phosphoglycerate. Again, if you see here, ATP is involved, so it will end with kinase. What kinase? Phospho. Glycerate is involved. See, phosphoglycerate. So we write glycerate kinase. Phosphoglycerate kinase is the enzyme. Next, 3-phosphoglycerate is getting converted to 2-phosphoglycerate. Many people think that here also isomerization is taking place. But no, here it is not isomerization. Here the enzyme used is phosphoglycerate mutase. What is the enzyme? Phosphoglycerate mutase. Okay? This is the only step of confusion which we have to remember. Otherwise, all the other steps, the enzymes, we can derive them maybe from the precursor or maybe from the successor. Okay? Then conversion of phosphoglycerate to your phenol, that is the PET, takes place through the enzyme enolase. Okay? Here it is aldolase, here it is enolase. Okay? And then coming to the last, that is conversion of PET to pyruvate. Again, if you see here, the ATP is involved here, right? So again, it will end with your kinase. What kinase? Pyruvate kinase. Pyruvate kinase. Okay? So if you look, all the enzymes are here. The complete cycle along with their enzymes is on your board. Okay? Now, one last point I wanted to add. From here till fructose 1,6-bisphosphate, from your glucose to fructose 1,6-bisphosphate, here there is utilization of energy in the form of ATP. So these steps are studied under the side heading energy consumption steps. Okay, energy consumption steps. Here, fructose 1,6-bisphosphate is getting converted to dihydroxyacetone phosphate or glyceroldehyde triphosphate. This is called as your split reaction or split step. Because splitting is taking place. Okay. And here if you see these steps, here the ATP is being produced. Energy is being produced. So these steps, these are called as your energy producing steps. Okay? So this is it, energy consumption step, split step and your energy production step. So this completes the glycolysis concept. And in my next video, we will be discussing about each step. Each step in detail is not required for me. Okay? For me, this is enough. Okay? Thank you for watching.